Questions 21 through 25 on the 2012 Grade 8 Gauss Math Contest. All three scales shown are balanced. One possible replacement for the question mark is. We have to think about this. Something has to balance two squares. Okay, well, let's talk about this. Two squares. Well, let's see. This one tells me that one square and one triangle is equal to two circles. All right. So, how does that help me? Well, one square and two circles. Well, if I were to subtract a triangle from each side, then that would leave me with two circles, subtract a triangle like that. Okay, perhaps that helps me a little bit. Well, I'm interested in two squares, so what I'll do is just multiply the other side also by 2. So now I've got 4 circles, subtract 2 triangles. Well, none of it looks like here. There's no subtraction there, so somehow I've got to combine it all. Okay, well, I've got to then, of course, use this one then. Somehow, some way, I've got to use that information. And what I'm going to do is I'm going to keep these two circles, and then I'm going to break it up into two circles. So I just broke those up, and then subtract 2 of those guys. Now, the two circles, that appears in a lot of these, so I'm going to keep those. Let's see if I can combine these guys. 2 circles and 2 triangles. Well, 2 circles, I can get a relationship with that. 1 circle is 2 triangles, so 2 circles is 4 triangles. Like this. So that basically means I've got 2 circles. 4 triangles minus 2 triangles is 2 triangles. And there we go. 2 circles and 2 triangles together. And of the answer choices, that's D. 2 circles and 2 triangles for number 21. In downtown Gaussville, there are 3 buildings with different heights: the Euclid, the Newton, and the Galileo. Only one of the statements below is true. The Newton is not the shortest, the Euclid is not the tallest. Sorry, the Newton is not the shortest, the Euclid is the tallest, the Galileo is not the tallest. Ordered from shortest to tallest, in height the buildings are. Well, we have to do a little bit of legwork here. So we got the shortest one, then we have the building that's sort of in the middle, and then the tallest one. So the hope is that the first scenario that we try works. If it doesn't, that's okay. We try another one. So let's try this scenario. Let's say this statement is true, and then these two are false. Let's see what happens. If the first statement is true, the Newton is not the shortest. Well, that means it's not the shortest, so it's not here. It's either here or here. I don't know which one, but it's one of those two. It's either the middle one or the tallest one. The next statement, the Euclid is the tallest. Now that's a false statement according to what I've labeled. The Euclid is the tallest is a false statement. So the Euclid is not the tallest. So the Euclid is either here or it's here. Next statement, the Galileo is not the tallest, is a false statement. So that means the Galileo is the tallest. So that means G here. Can this be combined? And the answer is yes. We can make the Euclid the shortest, we can make Newton the middle one, and we can make Galileo the tallest. If we do that, it becomes ENG from shortest to tallest, and that is the answer. So I got lucky on the very first try. I got it right. So number 22, the answer is C. Different patterns can be created by shading exactly 3 of the 9 small triangles shown, no 2 of which can share a side. Patterns that can be matched by rotations or by reflections are considered the same. For example, the following patterns are considered the same. How many different patterns can be created? Now, why are these all the same? Do they look the same? Well, what they've done is either a reflection or a rotation. So for example, when you took this one and just reflected it in the middle, let's say you got this one here. As you can see, it's just reflected as if you were doing a mirror reflection with the mirror being right down the middle. Now this one here, this one is a little bit different. This is a rotation. If you take this guy and then rotated it, just rotate your paper. If it's written on a paper, rotate it and you'll see it'll end up like this. So it's a challenging question considering the fact that you got a time constraint. So there's got to be some way of making this easier. I guess that's a simple way of saying it. And the good news is there is. What you do is you break it down into different categories, and the categories I'm going to choose are corners. So number of corners. And when I do that, hopefully it'll make it a little bit more digestible. So the first thing is all 3 corners, 2 corners, 1 corner, and 0 corners. So here we go with the first scenario. So here is the first one where we have obviously 3 corners all shaded in, and those are the ones that have been selected. And as you can see, there's only one way of selecting all 3 corners as shown. So this gives me one possible way of selecting 3 out of the 9. And if you rotate this and reflect it, it will end up similar. So there's only one way. Now, since that is relatively straightforward, let's move on to 2 corners. If we choose 3 in such a way that 2 corners are being selected, it can be either done that way, or this way, right? And it becomes a little bit more challenging, of course, because now we have to choose a third one in such a way that it's not the same. So if you put it here, that covers a lot of ways. As you can see, it's a straight line. So if it was these 3 or those 3, those would be the same. So those ones don't need to be talked about because those are reflections or rotations. Now if I put the third one here, it is different, as you can see, than this one here. And then if I put the third, if I select the third small triangle to be here, it also is different. So these are 3 unique selections, and they involve all 2 corners. Now let's move on to 1 corner. So this gave me 3 additional. This is 1 corner. With 1 corner, as you can see, I've just chosen the top ones. Now we have to figure out, how do I select the other 2? And these are the possibilities. These 2, or these 2 up here, or these 2 down there. And all of those are unique. Even if you rotated them or reflected them, none of these are the same. None of these 4 are the same, even after rotations or reflections. So this gives me another 4. And then finally, the one that has 0 corners selected, 0 corners, there's these 2. You can have these guys or you can have these guys, and those are, of course, are not the same. So those give me another 2. So I've got, let's see here, 1 up here, 2 down there, 3 and 4, so what's that? A total of 10. And in my opinion, this is a challenging question considering you got this time constraint on math contests. So 10 is the answer, and therefore that would be, for number 23, the answer is C. Stones are numbered 1 through 10. 3 groups of stones can be selected so that the sum of each group is 11. For example, one arrangement is 1, 10, 2, 3, 6, 4, 7. Including the example, how many arrangements are possible? We've got 3 groups. Okay, that is well defined in the question. Each of these groups has to total 11. So how do we do this? Well, the first thing I'd like to concentrate on is how many are in each group. Can I have 1 stone in a group? The answer is no, because my numbers only go up to 10. I cannot have 1, because 1 stone could never equal 11. The highest is 10. So the stone has to be at least 2. How about the second group? Well, again, we can't have one. I can have at least two. And the third group, again, it's got to have at least two. Okay, that's one possibility, and I'll talk about all the different types. But I first want to figure out the size of the groups. How about the next scenario? Can I have 2, 2, and 3? Can you make a group of 3? And the answer is, of course. They did it in the question, so that's right. What about 2, 3, and 3? Can I make 2 groups of 3 and 1 group of 2? And the answer is no. The answer is no, because what happens is if you take out a group, right, like 2, 3, 6, I can't make another group of 3 because those 3 numbers have been taken out. In order to make another group of 3, for example, 1, 2, 8 is another group of 3, right? That adds up to 11. I can't make this group because I've already taken out a 2. See what I mean? So no matter what you did, let's say, well, okay, well, 1, 2, 8. Well, how about another group of 3? You can make 1, 3, 7. Yeah, but I've already taken out a 3. I can't make 1, 3, 7 if the 3 is gone. Or you say, okay, well, I know. How about if you did 1, 4, 6? No, because the 6 has already been taken out. I can't make 1, 4, 6. So there's no way to have 2 groups of 3. So this one can't do it. Okay, so these are the only 2 possibilities. Either you have a group of 2, then a group of 2, a group of 2, or a group of 2, a group of 2, and a group of 3. All right? So that's the first and foremost, the size of the groups. Now let's talk about what's in the groups. Well, if you look at this one first, they have actually given you some pretty good clues. It could be 110, 29, 38, 47, or 56. These are the only possibilities for a group. Now, if I chose, let's say, 110 for the first, if I put 110 here, well, my next group here has to be one of the other 4, right? So that gives me 4 choices. So 4 choices. And then let's say I put a 29 there. I'm just giving an example. That means this one's gone. So now for the last one, I've got 3 choices. I've got these 3 guys to choose from. So for the first group, I had 5 choices. For the second group, 4 choices. For the third group, 3 choices. So 5 times 4 times 3 is 60. Now you say, whoa, that's a lot. That's higher than all the answer choices. How can that possibly be right? The reason is because each of these has 3 iterations. So you have to divide this by 6. And when you do, you get 10. Now you say, well, what do you mean by 3 iterations? For example, here I chose 110, 29, and let's just say the last one I chose 38. Well, this is the exact same as 110, 29, 38, right? That's the exact same as 110, 38, and 29. You see what I mean? The order, if you change it like that, it's the exact same set of 3. And similarly, 29, 110, 38, and similarly 29, 38, 110. And the last 2 is when you put the 38 first. So 38, 110, and 29, or 38, 29, 110. So as you can see, each of those combinations produces 6. So each of these 60 produces 6 that are the same. And therefore, you got to divide that 60 by 6 in order to get a unique number of combinations. That's 10. Okay, well, that's good. We've got an answer so far that's close to the answer choices. Now we've got to look at this guy. We've got a scenario where you have 2, 2, and 3. Okay, for the 2s, we are an expert. We know it's either 110, 29, 38, 47, or 56. Correct? And this 2 obviously will involve the same ones except one that you've already chosen. So for example, if I chose 110, it's going to involve any of the other 4. But what about 3? How do I make a set of 3 that add up to 11? Well, one of them they gave you. Those are as follows: 1, 2, and 8. That will add up to 11. 1, 3, and 7 adds up to 11. 1, 4, and 6 adds up to 11. 2, 3, and 6 adds up to 11. And the last one, 2, 4, and 5 would add up to 11. Now here's the thing. It's not as simple as just saying 5 times 4 times 5, because some of these cannot be made. So we have to carefully see what can be made. If this is selected, which one of these can I make? And the reason it's not that straightforward is because some of these cannot be made, as you will see. So let's say I chose 1, 2, 8. Which one of these can I now make? Well, the 1, 2, and 8 are gone. So I can't make this one, or this one. I can only use 4, 7, and 5, 6. Correct? So I can use either 4, 7 here or 5, 6 here. Or I can use 5, 6 here and 4, 7 there. But it's the same set. So for 1, 2, 8, there's only one set that's 1, 2, 8, along with 4, 7 and 5, 6. Right? Any other iteration of this is the exact same set, so we don't need to worry about those. So I got one possible. For 1, 3, 7, okay, the 1, 3, and 7 have already been selected, so I can't use anything that has a 1, 3, or a 7, because those stones are gone. So the only thing that's left is 2, 9, and 5, 6. So if I choose 1, 3, 7, I would be able to choose either 2, 9, or 5, 6. And that gives me one more set. So I think by now you're getting the hang of this. So similarly, if I chose 1, 4, 6, the only ones I can choose are 2, 9, 1, 4, and 6 are gone, right? 2, 9, and 3, 8. That gives me one more. If 2, 3, and 6 are chosen, the other two sets, let's see, 2 and 3 and 6 are gone, so 1, 10, and 4, 7 are the only ones that I can make. And then finally, if 2, 4, 5 is my set here, I can't choose 2, 4, or 5, so I can choose only 1, 10, and 3, 8. And there we go. So these are the only possibilities. So this gives me 5, and then I had 10 up there. So 5 plus 10 is 15 grand total. So number 24, the answer is E. In the rectangle WXYZ, the parallelogram PQRS is formed as shown. The segment PT is perpendicular to SR. The length of ST is. They want you to find the length of that small segment ST. Okay, well, several ways of doing this question here, but one way is just to look at the areas. The total area, TA, of the entire big rectangle, we can easily figure out. Length times width. The length is 3 plus 12. Those dimensions have been given. And the width is 4 plus 5. So very quickly, we get this is what? The 15 times 9. And that is 135. So that is the area of the full rectangle, the big one. Now I want to concentrate on the area of that parallelogram. Well, that is PQRS, and the area of the parallelogram is going to be the total area minus these little triangles. So if I take the total area and subtract that triangle, this triangle, this triangle, and this triangle, I'll get what's left, which is the PQRS. So total area minus the 4 triangles. So this triangle and this triangle are the same. So it's really 2 times those 1/2 base times height, since they have both the same dimensions. And then this triangle and this triangle are also the same. So instead of subtracting them individually, I can just combine them. 2 times 1/2 base times height, which is 12 times 5. Well, total area I just got was 135, and this looks like 12 and 60. So 135 minus 12 minus 60, and that is 63. So that is my area of PQRS. Now, the area of PQRS can be calculated by length times width, or length times height. This is the length and this is the height, since PT is perpendicular. PT is perpendicular, and therefore it can be used as the height. So PQRS, the area, is PQ, which is the length, times PT, which is that height, since it's perpendicular to SR. Well, PQRS we know is 63. PT, we don't know that. That is something we obviously will need to figure out. And PQ, we don't know right now, but I can figure out PQ pretty easily using Pythagoras, using this triangle right here. So PQ squared is 12 squared plus 5 squared. And that's 144 plus 25, and that's 169. So take the square root to get PQ, and that's 13. So 13 goes here. So that means PT is 63 over 13. But they don't want PT, they want you to find ST. ST is right here. Well, that shouldn't be a problem. I can use that triangle and the Pythagorean relationship. So my final step, I've got PT squared plus ST squared is equal to PS squared. Now PS, we haven't calculated yet, but we can do that easily using Pythagoras. Some of you even remember what that is. If one side is 3 and the other side is 4, what is the hypotenuse? But just in case you didn't, we can do it really quickly. 3 squared plus 4 squared is equal to PS squared. That means this is 9 plus 16, which is 25. 25 is PS squared, so PS must be 5. So there we go. So PS squared is going to be 25. And then PT, we just figured out, was 63 over 13 squared, and then ST squared. So ST squared is going to be 25 minus 63 over 13, all squared, like that. Okay? And you can do this in fractions, or you can do it in decimals. It doesn't matter. In the end, as long as you choose the right answer, that's all that matters. I did it in decimals, actually, and I get ST squared to be 1.5147. And then if you take the square root, I got ST is equal to 1.23 approximately. And of all the answer choices, the one that matches 1.23 is choice D, 16 over 13. If you did this in terms of fractions, you would get exactly 16 over 13. It's up to you, whichever way you feel most comfortable. So number 25, the answer is D.